So hi, I'm Edison again, and let's take a look this time at something that sort of follows up on what we looked at last time. Last time we talked about static electricity, or what can be done when electric charge, or in particular electrons, can go from one place to another, but they don't really flow around. They can go from one material to another and stay on the surface of that material, and we see different things that they can do. Well, now let's look at the idea of what those electrons can do if you have enough voltage. Remember, voltage is just electric pressure. Similar to these two magnets, they stick together this way. If I turn them around so their matching poles are toward each other, or both have a north pole and north pole toward each other, they repel, and they really don't want to be together. So there's a certain, if I hold them together, I have to put a lot of effort into it, and if I release them, right, one shoots off and goes away. It's because light, it's related to the idea of light charges repelling each other. Now, these electrons and protons are not really magnets, but this helps us get an idea in our head, so we can say that this is a model somewhat of how they act. So if we want those electrons to move from one place to another, we have to put some pressure on them. We have to push them, and that push is called voltage. So really, when we talk about a battery, all a battery's job is to provide some voltage, electron push or electrical push. So those electrons can leave one place and actually go to another place. So let's take a look at some of the requirements for an electrical circuit. You may have heard the word an electrical circuit before. An electric circuit just means this, that an electron, or electrical charge carriers, will go from one place to another, and they go in a circle. So they start out at one place, and then they go to another, and in order for a circuit to happen, you have to have a closed circuit. There must be a loop, and there can't be any breaks in that loop. So one of the kind of neat things you can buy locally here, Hobby Lobby has these, and you can order them online. They've gotten kind of cheap now with a coupon around $4, so that's not too bad. But you may have seen these before. They have a bunch of different names depending on the brand you buy. But in the toy section of Hobby Lobby, you can find these, and really they are nothing more than circuit testers. So you could hold on to one end and hold on to the other, and as long as there is an electrical circuit in between, there's a tiny battery inside with some LED lights and a little microphone inside and a little circuit that makes a funny sound. And so as long as you're connecting a circuit, then you get the sound with the lights and all, and they're kind of fun. So you know that an electrical circuit has been made when you connect the two ends together and you hear that sound and see the lights. So if I'm holding this and I come close, there's not a circuit. I've broken the circuit. And really here, the electricity is just going through me to the other side. So if a circuit is broken, nothing happens. So there's something providing electrical push in there. It's a tiny battery, and that electrical voltage, that push of electrons, it's inside, but right now there's nothing pushing. So, or there's a push, but there's no way for that charge to flow. So if I grab that, now we have a circuit. So there are different things that are really good at conducting electricity, conducting the flow of electrons, and there are some things that are not good at conducting or the flow of electrons. So if something is really good at conducting, we call it a conductor. Metals are good conductors. So if I took this, and I'm a decent conductor, and so if I took this and this and pressed them together, we see that electricity is flowing through that metal nail. So let's try something else. Here's an electric, actually a wire, and you can see that I've cut off the plastic insulation, and we call it insulation because it insulates, and I'll tell you what insulators do here in just a moment. So I'm going to hold on to the end of this wire, and there's copper wire on the inside of this. So if I connect these two together, we see that that wire is a good conductor of electrons. But notice this, if I hold on to the plastic covering and I touch the plastic covering over here, there's nothing. So there are some materials, like this plastic, that are not good at conducting electrons. And so there are some good conductors, and there are some good insulators. An insulator is something that doesn't allow electrons to flow very well. So when you're making an electric circuit, you need something to push the electrons. You need a voltage source. A battery usually does it for us. There's a little battery in here. You need a closed circuit made up of a conductor. And as long as you have that closed circuit made of a conductor, you have an electric circuit. Let's take a look at what else. Here's a paperclip. Paperclip's made of metal, so you can make a prediction about what you expect to see. And you expect to see that happen because a metal conducts electricity. This fur here, however, earlier we could see that this rubbed against the PVC pipe. We know that electrons move from one place to another, but they only move from one place to another. They weren't flowing through a circuit. So the electrons, once I build them up here, you can hear the crackling. Once I build them up, right now, they're staying in place. So there are electrons and there are protons, there are atoms in non-conductors or insulators, but the insulator does not allow the electrons to move very well. They stay in place. So the buildup of electrons really stay right along in here. So in a metal or in any good conductor, the electrons can flow as long as something is pushing them and they have a place to go. This paper towel here, let's take a look at that. So I'll touch it to the paper towel, and I'll touch over here, and we see that there's nothing. Let's take a look at this water, though. Now, this water is just tap water, and water, it's kind of curious, water itself is not a good conductor at all, but rarely do you have pure water. Usually there's a tiny mix of salts and minerals inside the water, and they can conduct electricity. So there are tiny bits of salt, various types of salts in the water. That's what makes water conductive. So water from the tap water does have these impurities in it, so I can press this into the water, touch that to the water, and I can touch the other side, and let's see if this water conducts electricity. We see that it does conduct electricity. So that's why it's very important for us to be careful around water and electricity, like in a bathroom or in a kitchen. And very often now that those electric outlets in bathrooms and kitchens are a little bit of a distance away from water sources. And part of that is for safety's sake. Now, what if we took this and actually poured it in the paper towel? And now the paper towel is going to soak up some of that water, which does conduct electricity. Remember, the paper towel didn't conduct electricity before. Let's try it now. I press here, and I touch here. And we see now that the salts and the impurities in the water are helping that water conduct electricity. So, there are a lot of different things that do conduct electricity. You may have heard of squishy circuits. Squishy circuits have been around for several years. You may have played with them at school. You may have read something about these on the internet. And you can go to the internet, try YouTube and a whole lot of other places, and search for squishy circuits. You can make your own material. And really, what I have here is the same thing, except I went and bought this at Walmart. This is just Play-Doh. And Play-Doh is, you can make your own at home. There are all kinds of recipes you can make. But Play-Doh is full of salts and chemicals that actually conduct, like the water, by themselves. They don't conduct electricity, but when you add those salts and those impurities in the material, it actually helps it conduct electricity really well. So I can test this Play-Doh here, and we see that it does conduct electricity. It allows for the flow of electrical charge through this. Now on this circuit with this Play-Doh, Play-Doh does need a little bit more of electrical pressure or voltage for it to actually allow for us to close a circuit and create an electrical circuit. So I'm going to connect two 9-volt batteries together like this. Notice that the terminals, one is a positive terminal, one's a negative terminal, and they're labeled positive and negative terminals. And so notice how they can stick together, which allows you to have now not 9 volts, but now 18 volts. So you have quite a bit of electrical push or pressure on those electrons to actually move. So let's connect one to this one, and we'll connect one around here. And because Play-Doh, as well as squishy circuit material, homemade Play-Doh, as long as you add the salt that the recipe calls for, or some other impurity, and there are different recipes online, as long as you add the right impurities, they will be conductive. So right now there's not a closed loop, but let's see if we can close that loop with this. Remember, with the LEDs, electricity only flows one way. So, and we get the right way with that. And all of these LEDs are a little different than some you may have seen before. All of these look clear, but until you actually get them plugged up into a circuit, it didn't light up. So I'm going to turn this around. So the electricity is only going to flow in one direction through an LED. So let's find that. There we go. And so you can play around with all sorts of ideas related to this. You can go online. I won't try to remake the wheel, but there are all sorts of really neat activities. If you go to the Squishy Circuit website, well, or at least search for that on YouTube, then they have posted all sorts of really interesting ideas. Now again, you don't have to actually buy any of those, because as long as you have a couple of batteries, you have Play-Doh, and or do your homemade squishy circuit material, which uses water, oil, vegetable oil, some salt, depending on whether you want it to conduct electricity or not. I think their recipe has cream of tartar and flour. So with those things and different mixtures of those things, you can create your own material. But all you need is batteries, really, and some LED lights. There are other things. They have different speakers and different sound devices that they use, but really you don't need those, and you can do all sorts of things just with these. Again, the library will have some of these if you're interested, and you can come pick them up at no cost to you. So you can also start learning a little bit more about circuits and what they are and what they are not. Now, watch what I'm going to do. I'm going to take this, I'm going to connect these two ends together, and notice that the lights get more dim when I do that. So think about it. What's happening is you have a flow of electrical charge coming through these circuits, or coming through the circuit, but there's no electrical charge flowing here. So really I could cut off this part and this part, and nothing really happens to the lights. The lights are still going to light up. I can cut it off here, and I can cut it off here, and it doesn't really matter because there's no electrical charge being pushed by the voltage, which is the voltage source of the batteries. They're not coming through here. Now, once I hook them back up together, now notice you only have a certain amount of charge flowing. Well, if I connect these are still lit up, and these are much more dim. What's happening is you actually have some electrical charge flowing through here, and that means there's less to be able to flow through these. So it gets more dim. Now it's brighter. Now electrical circuits, if you learn about actually wiring up electrical circuits, metal wires are a little bit different than this and how they behave, but you can start experimenting and understanding what's really happening with the flow of electricity by playing with Play-Doh. You can also use other things that will allow for the flow of electricity. Remember, what I'm holding is this plastic coating, the insulator part of these wires. This material doesn't allow electrons to flow well, but the copper inside does a really good job at allowing electrons to flow.
So we can also actually connect these, and this becomes sort of a jumper. And so the same thing happened here. We could take this, let's move these around, and now I know electricity is flowing, but let's do this. And so I can connect it with this. So I can break that. We've opened the circuit. Electricity does not flow through an open circuit, only a closed circuit. So let's connect and close the circuit with this. Remember, electricity only flows one way through an LED. So if we turn it around, and now we have that. And we can also break the circuit at several places and reconnect it with our LEDs. Let's try this. I'm not sure what's going to happen. I have an idea what's going to happen, but let's find out how well this works. I'm going to plug this in here. And remember, I'm a part of this circuit, so I'm not sure if this is going to work, but we'll find out. So it does. So now I have become a part of that circuit. Now these LEDs have become really dim because that flow of electrical charge has a lot more to push through now. So there's more resistance resistance to the flow of electricity through this circuit that I am included in now. And so because of that, you don't have quite as much charge, or you don't have quite as much electrical charge being able to power these, or as much voltage being able to power those lights, I should say. All right, so there are all kinds of things you can play with. There are all kinds of ideas. We could connect these together. We could connect these together. We could connect these together. We could connect these together, and these will light up now. And you can now have a switch you can make to turn things on and off. Let's try connecting this with this and that, and now we have our circuit. And really you could keep adding more and more and more. Notice this is not going to light up, and if I turn it around, it's not going to light up. There's something curious happening, and why that will never happen, although I could put it over here, turn it around the right direction, so still nothing happening. But yet if I put it between two wires correctly, now it lights up. I want you to think about why that is. There's some curious science behind it, and a lot more involved than what we have time to explore now. But the more you play around with these ideas, the more you learn. The more you learn, the more you learn. As you learn one piece and start to come to one understanding on something you couldn't understand, suddenly there's something else that comes to mind, and something else, and something else, and something else. And where it stops is really up to you. You can keep learning and learning and learning and learning and learning, and eventually you realize you can look back and you've learned because of playing with Play-Doh. So there's the idea of a squishy circuit. You can make your own. You can use Play-Doh with some batteries, some LED lights, and some Play-Doh or squishy circuit material that you make from scratch at home. For only a very few dollars, you can come up
with all sorts of different things that allow you to learn a lot more about how electrons and atoms work.